Hi, my dear students. Good morning to all. Welcome back to Maths online class. So, in previous class, we discussed on prime factorization and one method of prime factorization. What was it? Factor tree. Now, what is remaining? Long division method. So, all of you understood what is prime factorization and practiced questions on factor tree method. So, today we can discuss on prime factorization by long division method. So we can look how can we factorize, prime factorize using division method. Take one example 36. So we have to prime factorize this number 36 using the method long division method. Division method we are prime factorizing. How we can see? Division method means normal division but not the case of normal division. Here we have to prime factorize 36, isn't it? So we have to use prime numbers only. When we are dividing, you are using only prime numbers. Here we are using the concept of divisibility rules. Means here we can take by checking the divisibility rule. Here 36 is an even number, isn't it? So we can start with 2. You know 2 is a prime number, isn't it? So we can start with 2. When dividing 2 with 36, what you are getting? So I divided 36 with 2, I got 18. If you don't know the division, you can work it out in the working column and divide. So when 2 divided by 36, 36 is divided by 2, we are getting 18. Again 18 is a even number, so we can use 2. 2 is a factor. So 2 in 18 how many times? 9 times. Now 9 is not a even number, so we cannot use 2. But which number we can use? 3. We cannot use here 9 because 9 is not a prime number. We can use only what? Prime numbers here. Because we are doing prime factorization. So use only prime numbers here. So we are using here 3. 3 in 9 how many times? 3. Again we have to make it 1. So 3 we are writing here. 3 in 3 how many times? 1. So what is the prime factorization of 36? 2 into 2 into 3 into 3. See, why this is known as prime factorization? Because we are using only prime numbers to divide. Don't use any composite number to divide. Then it will not be a prime factorization. Here you know for 36, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor. Don't use 4 and 6 because 4 and 6 are not prime numbers. So use only prime numbers in order to you have prime factorization. So what is the prime factorization of 36? 2 into 2 into 3 into 3. So from the name itself, long division method means something related to division. Now by seeing the example you understood, we are dividing the given number with its factors. The only thing is that we have to divide with prime numbers because we are doing prime factorization. So long division method is similar as division itself. We are dividing here with its prime factors. So we can look some more examples. Example 75. So we have to prime factorize 75. So you don't know what is the number to be used here. By you looking the divisibility rule, this number is ending up with 5. So which number will be divisible with this number? 5. 5 is a factor for 75. So you can start with 5 here. So when 75 is divided with 5, we are getting 15. Again 15 is divisible by 5. So I used here 5. So 5 in 15 how many times? 3 times. So 3. Here 3 comes means it's a prime number. So only factor is what? 3 itself. So 3 in 3, 1. So what is the prime factorization of 75? 5 into 5 into 3. So when you're after factorization, just confirm that all the numbers you used here are prime numbers. 5 is a prime number, 3 is also a prime number. So the prime factorization of 75 is 5 into 5 into 3. Example is 91. So you know 91 is not an even number. So it is not divisible by 2. Also it's not ending up with either 0 or 5. So we cannot use 5 also. Now remaining is the 3. So what is the divisibility rule of 3? What is divisibility rule of 3? Add the digits. 9 plus 1, 10. Whether 10 is a multiple of 3? No. So it's not divisible by 3 also. So next which is the number? 7 is a prime number. So we can just divide and check 91 with 7. 4 is composite number, 6 is composite number, 8 is composite number. So in between 7 we have. So we can check whether this number is divisible with 7. Divide and check 91 with 7. So when we divide 91 with 7, it's divisible. Also we are getting the quotient 13. So it is divisible by 7. So the 7 we can use here. Now what about 13? Whether 13 is a composite number or a prime number? 13 is a prime number, isn't it? You have find out prime numbers and composite numbers between 1 and 100. So from that you can see 13. 13 is a prime number. So the factor for 13 is 13 itself, isn't it? So the prime factorization of 91 is 7 into 13. See, here we are using the divisibility rules in order to check which number we can use here. By applying the divisibility rule, we can say that 2, 3, 5 is not divisible with 91. Then the remaining is 7. We have to use prime numbers here. So just divide. You don't know the divisibility rule of 7. So just divide and check 91 with 7. So it is, we are getting remainder 0. We have to get remainder 0. Then only we can say this number is a factor, isn't it? If you are getting any other number remainder, we cannot say it's a factor. So here, since we are getting remainder 0, we can say 7 is a factor of 91. So what is the quotient here? We are getting 13. The 13 we wrote here. Now 13 is a prime number. So we can stop it there. So the prime factorization of 91 is 7 into 13. Example 88. Factorizing 88. You know 88 is an even number. So we can start with 2. So 2 in 88 44 times. Again it's an even number. Start with 2. 2 in 44 22 times. Again it's an even number. 2, we are getting 11. 11 is a prime number. So the only factor for 11 is 11 itself. So 11 into 1. So what is the prime factorization of 88? 2 into 2 into 2 into 11. Just confirm your answer is correct. 2 into 2 is 4. 4 into 2 8. 8 into 11 is 88. So this is division method. It is similar as our common division itself. If you don't know to divide it like this, you can divide it in the working column and you are writing the quotient here. Once you are dividing, you should get the remainder 0. Then only we can say this is a factor. One more example, 60. So we are prime factorizing 60 using division method. So here 60 is an even number. So starting with 2. So in 60 when divided by 2, you are getting 30. Again 30 is an even number. Dividing with 2, you are getting 15. Here 15, either 5 or 3 you can use. I am going with 3. 3 in 15 how many times? 5. Again 5 is a prime number. So 5 itself. Here 60, 2 is a factor. Similarly 3 is also a factor, 5 is also a factor. So if you are starting with 3 or 5, that also your prime factorization is correct. In any case, the prime factorization will be same. Here we started with 2 and we got the prime factorization 2 into 2 into 3 into 5. Here I started with 3 because 3 is also divisible with 60. So when I divided 3 with 60, I got 20. Again 20 is not divisible by 3 but it's an even number, so we can use 2. Now 2 in 20 10 times. Again it is an even number, 2 we used. 5 is a prime number, so 5. Here I started with 5 because here this number is ending up with 0. So we can use 5. So 5 in 60 12 times. Now 12 is an even number, started with 2. 2 in 12 6. Again 2 in 6 3 3. So if any case any number you use here for 60, 2 is a factor, 3 is a factor. Also 5 is also a factor. So if you can use any prime number and any factorization, but the final factorization will be correct. Here 2 into 2 into 3 into 5. Here 3 into 2 into 2 into 5. Here 5 into 2 into 2 into 3. The numbers are same, just the order only different. So what is the prime factorization of 60? 2 into 2 into 3 into 5. So any order you can start any number, but the only fact is that number should be a factor. Here 2 is a factor, 3 is a factor, 5 is a factor. So with any of this number, you can start the division. So in today's class, we discussed on the second method of factorization, prime factorization, that is long division method. So now you know what is factor tree method and long division method of prime factorization. Copy down the notes given and attend the test paper. In your textbook, there are some more questions. Please work it out by yourself. We'll meet with the next concept based on this class tomorrow. Bye.